Hey, it's our Paralyzed Math Industry, and we are going to take a look at detours. So, in geometry, detours are not a type of property used in a proof, but it's the type of proof that we're going to use, because the movements and what we prove is going to be surprising, and that's what a detour is. But before we start the math, when you think of the word detour, you probably think of this. That is correct. A detour happens when something is blocked off and you have to go somewhere else. So here is the math part. Here is the proof. Given AB segment is congruent to AD. So we're going to say AB is congruent to AD. BC is congruent to CD. We somehow have to prove that triangle ABE and ADE are congruent. So we have to prove that that triangle and that triangle are congruent. So we already have our givens right here because they are literally given to us. What can we do? Well, if you take closely attention to the diagram, you see these two congruent segments and these two congruent segments. What we can do is try to look for a triangle and see what else are congruent with those parts using CPCTC. Then we'll continue on with the problem or the proof. We can understand that AC is its very own line. So we could say AC as a segment is congruent to AC. The reason why is reflexive. It's literally its own line. Now we can understand that we have a side, and a side, a side, and a side. So we're going to turn these all into side. We can now say SSS or SSS, and we can prove that triangle ABC is congruent to triangle ADB, but ADC. So what we have proven is, I'm going to highlight in red, this right here. But there is one little problem. We proved two triangles are congruent. However, they are not the right kind of triangles we wanted. We want the smaller triangles, not the bigger ones. But that will still help us later. Because remember how we used SSS? Then we could say that these two smaller triangles are sharing the same angle as those two bigger triangles. So the green triangles are basically sharing the same angle A as the rest. So we can say that angle BAE is congruent to angle DAE. So BEA, DEA. And we could say it's CPCTC because those are the parts of the larger two triangles. So now let's put angles right here. We are still trying to find that if these two triangles are congruent. We already looked for the proof of one triangle, or one set of triangles, but who says we can't do the proof of the other set of triangles? Notice here that these are also smaller congruent triangles. So after we've proven these two things, we want one more side because we can do side, angle, side. So currently, right here is going to be an angle. Then we could say that AE is congruent to AE. And the reason why we did that was we can say reflexive again. The reason why is when we do that, we have a side angle and a side. Side, angle, side. Let's do this. So, we already proved that AB and AD were congruent. We proved that AE and AE are congruent. We proved that these two angles are congruent. So now guess what we could say? We could say BAE as a triangle is going to be congruent with DAE. Yeah, I know I put them in different orders, but they're still staying the exact same triangles. We could say SAS. This was a side that was proven. And from the given, we could say that this was a side that was proven to us. We could use SAS. So, the reason why this was called a detour proof is because we are literally detouring from one triangle to merge onto the other triangle. So we are trying to prove that one bigger triangle was going to be congruent parts to a smaller triangle that was congruent to each other. So detour proofs happen when you have to use the same move or the same proofs or series of proofs over and over again, more than 2 times.
Start! Finish!
That concludes the video. I hope this video has helped you understand detours. Thank you for watching Top Picture Life's Math Industry. Like and subscribe.